Okay, good morning class. So today we're looking at trigonometry. At this point you have derived the double angle formula. For those of you who want to know how we derive the double angle formula, you can find the link to last year's lesson in the description box below. Okay, so at this point so we've derived those three formula. Alright, so we're looking at example 1 on page 96. Okay, so at this point, and this is for exercise 3 on page 96. Okay, so the examples, the exercise on page 98. Okay, 98. Alright, so just to refresh your memory, we came with 4 new identities. The one being sine of 2 alpha can be written as 2 sine alpha cos alpha. Then we got another one which is cos 2 alpha can be written as 1 of 3. The first one we proved was cos squared alpha minus sine squared alpha. Then we have proven 2 cos squared alpha minus 1, and we proved the other one which is 1 minus 2 sine squared alpha. Okay, so with a lot of practice, you'll know which one of the three to use when. Okay, there's no wrong one. Okay, so it's just that if you use the second one instead of we had to use the third one, it will just take you an extra step to get to the answer. Okay, so if it is that you just go with any random one, it should work out. Okay, and we'll just change the double and the squared identity to its equivalent later on. Okay, so those are the formula we're going to now use, your double angle formula. So the question says write sine 10a in terms of ratios with angles of 5a. So how do you think we're going to break this up? We've got sine 10a. Now sine 10a can be written as what? Sine 10a can be written as what? Sorry? What can this be written as? Remember, we're going to try and write it as double angle. Okay? But remember, there's also a 5a. So this can be written as 2 times 5a. Can you see that, people? So what do we have in place of alpha now? What do we have in place of alpha? 5a. So when we write it, it's equivalent, we're going to say it's 2 sine 5a cos 5. Does it make sense, people? Okay, because that is in a's place. You see that 2 is there? There's a 2. And we have sine, and there we have sine. People, does it make sense? Right, so let's write that quickly. That will simply give us 2 sine. What did we say? What is your alpha here? 5a. Cos. And there we go. That's where we stop. Okay, you see how easy it is? Alright. Not the O, it's a A. No? That's why you guys get confused. Let's look at the second example. Okay, this is example 2 on page 96. Example 2 on page 96. We are asked to write cos. We are asked to write cos of 8a in terms of sine 4a. So where do we start? We write it as cos of 2 times 4a. What is 2 times 4a? 8a. Okay. So what do we have in alpha's place now? 4. Can you see that, people? So we got cos of 2 alpha. But what do they want? They want sine of 4a. So which one of the three are we going to use? 1 minus 2 sine squared. Why are we going to use that one? Because that one has only sines in. If it said in terms of sine and cos, I would have gone with that one. If it had said in terms of cos only, I would have gone with the second one. Doesn't make sense. Any confusion? Okay. So again, in alpha's place, we have 4a. So this is the one I'm using. Okay. So it's going to be 1 minus. That is 1 minus 2 sine squared 4. Does it make sense, people? 1 minus 2 sine squared 4. Any confusion? Okay. Any confusion now? Right, let's carry on. This is the third one. Third example. The third example is also on page 96, correct? Huh? 96. Yes? Okay. Example 3 on page 96. The question says evaluate or determine or simplify would have all meant the same thing. Cos squared 15 degrees minus sine squared 15. So which one of the three is that going to remind us of? First one, dealing with the cos double angle. Can you see that, people? So the first one says cos 2 alpha is equal to cos squared alpha minus sine squared alpha. That was the first one. Okay? So what is in alpha's place? What is in alpha's place? 15 degrees. Can you see that? So in other words, this will be cos 2 times 15 degrees. Does it make sense? Right. Let's take this off quickly. So it's going to become cos 2 times the alpha angle, which is 15 degrees. What is 2 times 15? 13. 30. Now your special angles come into play. So the 30 degree angle. So it's going to be 1, 2, root 3. And what is cos of 30? The adjacent of hypotenuse, so it's root 3 over. Any confusion here? I'm moving too slow, no? Yes, I also feel that I'm moving a bit too slow here for you guys. Then move more to the right, okay? Let's go example 4 now. Example 4, and example 4 is on page 98. Okay. Right. So here we are asked to write 2 cos squared a over 2 minus 1 in terms of cos of a. What do you see there? 2 cos squared alpha minus 1. Is that? Yes, you can't say that. The second one. You all see it's the second one of the three. Okay? And what is on alpha's place? A over 2. Can you see that, people? So that means to say that cos 2 times a over 2 is equal to 2 cos squared a over 2 minus 1. You will understand. So let's clear this here quickly. So that I can write it as cos 2 times the alpha angle, as you said, was a over 2. You all agree with that? That cancelled, so we're left with cos of. Any confusion here? No? Still with me? Right. Sorry? Still writing. Okay. Alright. Let's carry on. Now the fifth example. Example 5 on page 96. Okay. Did I do it for now? No? Yes. Okay. This is example 5 on page 96. Alright. So here we are told that find cos of 2a. If sine of a is equal to negative 12 over 13 and a is greater than 0 but less than 270. People, cos of 2a can be written as any one of those three. Not so? That's right. However, the sine of a is our issue. Now, we can just assume that, we can just substitute and say, okay, cos of 2a can be written as, since the sine, I must use the one dealing with sine. Not so? So that is simply going to be 1, so what is, so sine of a is negative 12 over 13. So we're going to say cos of 2a is going to be 1 minus 2 sine squared a. Okay. So we said that sine of a is, what is sine of a? Negative 12 over 13. Okay, so that's going to be equal to 1 minus 2 into negative 12 over 13. And it must be squared. Okay. So work that out. We can put that in our calculator. So it's going to be 1 minus 2, open brackets, negative 12 over 13, close the bracket, squared. Going to give you negative 119, negative 119 over 116. Can you see that, people? Now say for argument's sake, you're the cos kind of girl. No? You say, now I want to use cos. Let's see what we can do for you then. Remember that cos of 2 alpha is equal to 2 cos squared alpha minus 1. Not so? But then I actually need to draw a diagram. Not so? So I say sine of a equals negative 12 over 13. And a is greater than 0 but less than 270. So it's going to be quadrant 1, 2 and 3. Which quadrant is sine negative? Quadrant 4 and 3. So which quadrant must I draw in? Quadrant 3. Okay. Let's pull this down here. So sine stands for opposite over hypotenuse. Negative 12 over 13. Apply Pythagoras, I get negative 5. You guys see that? And then this is your alpha angle there. So what do we have now? 2 cos. Cos is adjacent, which is negative 5 over 13 squared minus 1. Let's see how far off are we? 2 into negative 5 over 13 squared minus 1. Gives you also negative 119 over 169. Or if you wanted to use the first one, you could use the first one as well. You guys understand? Okay. But most of the time you would have to draw it. Okay, because if they give you sign there, they would ask you something more with the cos of 2a. Okay. So that's why I needed to show you how to do that there as well. Number 6. Question 6. Example 6. This was on page 96. Let's just draw this here, everything. Put this down here. Alright, example 6 on page 96. If sine of 40 is equal to 1 over a, determine cos of 80 and sine of 280. Cos of 80 and sine of 280. So, what do you think we're going to do here? Draw a diagram. Which quadrant would that be in? First quadrant. Why? Because that's between 0 and 90. It's a acute angle. So we don't actually need to draw the Cartesian plane there. So that is 40 degrees. What does sine stand for? Opposite over hypotenuse. So what's my opposite? 1. What's my hypotenuse? So how am I going to work out the third side? I'm going to work out the side here. I'm going to use Pythagoras. So it's going to be 1 squared is, sorry, not 1, yeah, it's going to be minus. Rather, so a squared is equal to 1 squared plus your adjacent side squared. Not so? So that adjacent side is what I'm calculating. It's going to be a squared minus 1. So the adjacent side is going to be the square root of a squared minus 1. Okay. You all okay with that? Any confusion? No? So now I can oh yes, and this angle here, what's the size of this angle? 50 degrees. So you fill that also in there. Okay? You all understand? Now we come to cos of 80. Cos of 80 degrees. So let's link 80 to 40. What would it be? 2 times 40. 2 times 40. So then become cos 2 times 40. So now we're going to go again with this cos angle here. The cos double angle. This cos alpha, what's in alpha's place? 40. Now I can use any of these three. Why? Because of the diagram I have. Once the diagram is sorted, your triangle is sorted, you can do sine, cos or tan. Not so? So that is simply going to be, which one you want me to use? 1 minus 2 sine squared. Okay? There we go. 1 minus 2 sine squared 40. So what is sine of 40? 1 over 2. Not so all from the diagram. Opposite of hypotenuse is 1 minus 2. 1 over a squared. Which is 1 minus 2 over a squared. What if I had gone with the other one? What if I had said cos of 80 is equal to cos of 2 times 40, and I went with the other one? Okay? So remember, this could have also been written as a squared is a squared minus 2. So if I get that, or that fraction, both would be correct. Okay? So if I use the one dealing with cos, it's going to be 2 cos squared 40 minus 1. So you say 2 cos, what does cos stand for? Adjacent, which is the square root of a squared minus 1 over a. And it must be squared. Okay? So what happens is, this would simply give us 2 into, now that square root cancel that square. So it's going to be a squared minus 1 over a squared minus 1. As you can see, LCM is a squared, so it's going to be 2a squared minus 2 minus a squared, which is a squared minus 2 over a squared. As you can see, it's the same. Can you see that? If I had gone with the first one here as well, you'll see you'll get exactly the same answer. Okay? And as I said, once you've got your diagram, you can use any of those things. Okay? You all okay with that? I'm going to take this off here because I need the space. Then it says sine of 280. So sine of 280. What can I do with 280? First we're going to reduce it to an acute angle, not so. So how do I do that? Which quadrant is 218? Sorry? Third quadrant. How do we get in the third quadrant? It's 180 plus, it's not in the third quadrant, it's in the fourth quadrant. It's over 270. Okay, my mistake. So it's going to become sine of 360 minus, sorry? 80. So 360 minus 80 is in the fourth quadrant. Sine positive or negative? Negative sine 80. Not so. So how can we link 80 to 40? Can it be negative sine 2 times 4? Now coming back to the sine identity. What is in alpha's place? What's in alpha's place? 40. So in other words, sine 2 times 40 is equal to 2 sine 40 cos 40. Does it make sense? Huh? This is why it's so easy, trigonometry. Because it makes sense to everybody. Huh? Yes, please. It would be nice of you. Okay, so what would that be, people? That would be negative 2 sine 40 cos 40. You all understand? No? But now sine of 40 is what? 1 over a. Sine of 40 is from this diagram. It's 1 over a. So just hang on, let us write it first. It's negative 2 times 1 over a. What is cos of 40? Cos is adjacent of hypotenuse. So the square root of a squared minus 1 over a. So this is going to simplify that. It's going to be negative 2 root a squared minus 1 over a squared. Okay. The last one quickly before you guys leave. It says prove that. Let's get the marker. That's it. Where it's coming from. We are asked to prove that cos of 3x is equal to 4 cos x minus 3 cos x. Okay. Pull this down here for the last time in this lesson. Okay. So people, which side is more complex? The left hand side or the right hand side? The left hand side. Okay. Now cos 3x can be written as what? Cos 3x can be written as what? There we go. It's cos 2x plus x. So what does that remind us of? The compound angle, not so. So the compound angle that I'm going to use there is of course cos alpha plus beta is going to be cos alpha cos beta minus sine alpha sine beta. Okay? So what is in alpha's place? 2x. So it's